In our next example of a discrete random variable, we're going to look to an example in meteorology. Suppose you are a meteorologist working on a 3-day forecast. You have determined that there is an equally likely probability of rain on each of the 3 days. Let x represent the number of days it will rain. So we were just given a very important piece of information, and that is what x represents for this particular scenario. Let x represent the number of days of rain. For part A, we're going to identify the sample points, which are also known as our outcomes, associated with this experiment by first drawing a tree diagram. So we have two possible outcomes. It will rain or it will not rain. I'll use R for rain and N for not rain. So on day 1, it could either rain or not rain. So I'm going to label that as day 1. Now from each of these branches, we are going to have another possible 2 outcomes, rain or not rain. So for day 2, that means another layer of branching. It will either rain or not rain. If we had no rain the first day, again, it's possible to have rain or no rain for the second day. So you can see the second layer of branching will represent outcomes for day 2. Now it says we have 3-day forecast, so I need another layer of branching. So if it rains the first day and it rains the second day, on the third day it could either rain or not rain. Following the next branch, it could rain the first day, it could not rain the second day, but then on the third day it could either rain or not rain. And as you can see, to follow the branches for no rain on the first day, rain on the second day, again, 2 outcomes, either rain or not rain, could occur. With the last branch, we could have no rain day 1, no rain day 2, but then it could rain the third day or it could not rain on the third day. So this last row of branching represents day 3. At the end of every branch, you will sometimes see the outcomes or the sample points written. Following the first branch of R, that represents 3 days of rain. So you might see that written as R. So what I'm going to do at the end of each of the branchings is to write the sample point. So I could have RN, then I could have RNR, then I could have RNN, then I could have NRR, NRN, NNR, and the last branch, no rain, no rain, no rain, that would be NNN. To write these sample points in their standard form, I would use S equals and then write down a list of those outcomes separated by a comma. So I'd have RRR, RRN, RNR, RNN, then NRR, NRN, NNR, finally 3 N's. So you can see there are 8 different sample points or 8 different outcomes. So that's part A. For part B, think about what x represents for this scenario and assign a value of x to each sample point. In order to do that, we need to know that R represents days of rain and X our variable that we're concerned with represents days of rain. So we want to know how many R's there are for every one of these sample points. So you can see x equals 3 for the first sample point because there are 3 R's. In the next sample point, we have 2 R's. So the x value would be 2. That represents 2 days of rain. Our next sample point has 2 R's. So again, x value is 2. In the next sample point, we only have 1 R. So that x value now is 1. For the next sample point, I have 2 R's, so x could assume the value of 2. Next sample point, there's only 1 R, so x assumes the value of 1. Next sample point, x value again is 1 because there's only 1 R. And there are no R's in the last sample point. So that's also important. We use 0 to show that there were 0 days of rain. By looking at each sample point, we were able to assign a value of x for each sample point. In part C, we're going to calculate the probability of x for each value of x and construct a probability distribution for the possible outcomes. So our values of x, or values that x may assume, are 0, 1, 2, or 3. To find the probability of x, we can see that there were 8 different outcomes. And we want to know, of those 8 outcomes, how many times did the x value assume 0? In other words, how many have no rain? And that's only the last one. So 1 out of the 8 is equal to 0.125. Now we're looking for x values of 1. There's 3 different outcomes that have an x value of 1. So 3 out of the 8 equals 0.375. Now we're looking for x values of 2. We have 1, 2, 3 different ones out of the 8. So 3 out of 8 is 0.375. And finally, how many times can x assume the value of 3? And we've got just one value there. So 1 out of 8 equals 0.125. So here we have our probability distribution. In part D, we're going to construct a probability histogram. So notice it says probability, not frequency. So a probability histogram for P of x. So our probability of x will be the vertical axis, and our horizontal axis will be x, which represents days of rain. We know that the days of rain can assume the values of 0, 1, 2, or 3. So I'll go ahead and write those in. And our other axis will have probabilities. And you can see I started out with a fraction and converted those fractions to decimals by taking 1 divided by 8 and 3 divided by 8. Since we're calling this probability histogram, we tend to use decimals. So I'm going to use 1/8 or 0.125, 2/8. We haven't use that in our table, but 2/8 is the same as 1/4, so that's going to be 0.25. 3/8 we calculated at 0.375. 4/8, that's the same as 1/2 or 0.5. And we really don't need to go any higher than that because 0.375 is the tallest bar that we'll need for our histogram. So to actually draw those bars, I'll go back to the table. So when x is 0, the probability is 0.125. And I like to write the probabilities above the bar so I know exactly what the probabilities are instead of trying to eyeball it. And then x value of 1 has a probability of 0.375. And probability for x value of 2 is again 0.375. And finally, probability for x value of 3 is 0.125. So you can see it's a symmetric histogram, isn't it? All right, so we have everything included. We've labeled the x-axis and probability of x. We've titled our axis days of rain. And this is now our probability histogram. For part E, we're looking for the probability that x equals 1 or x equals 2. So probability that x equals 1 or x equals 2. We interpret this as, what is the probability that there will be 1 or 2 days of rain? So the probability that x equals 1 in union with the probability that x equals 2 is what we're actually calculating. The word or is the union of those probabilities. So if we go back to the table, we can assign decimal values to x equals 1. That was 0.375. So 0.375 is added to the probability of x equals 2. Again, that's 0.375. So 0.375 added to 0.375 makes a total of 0.75. So the probability that there will either be 1 or 2 days of rain is 0.75. This problem will help you with the worksheet 4.2. So I hope you find this helpful.